An area I'm particularly passionate about is drones, thinking of ways that we can help enhance society by having a new perspective, an aerial perspective on the world. This presents methods to do monitoring that we've never done before, ways of delivering goods to people in remote areas that need these goods urgently, for example, vaccines. These are all areas that we can start addressing once we have this new form of mobility. Mechatronics is actually a blend between mechanical, electrical, and software engineering. So its significance is that it's really a very interdisciplinary engineering subject. You can think of it as the glue in engineering. Mechatronics develops automation and advanced manufacturing techniques that can be used in a range of different areas, from robotics to CNC machining, all the way to prosthetics. The Bachelor of Science majoring in mechatronics is your first step on this pathway. From your first and second years, you're doing hands-on engineering with foundational mathematics and science, setting you up so that you can move on to those third-year subjects, which are your special electives in mechatronics. At that point, you have an undergraduate degree in science with a major in mechatronics. You can choose to do an additional 2 years to get your Masters of Mechatronics in Engineering and come up with your accreditation as an engineer. Right from the get-go, you get to be able to work on hands-on engineering alongside researchers that are developing cutting-edge technologies. Everything from wind tunnels to rehabilitation robotics equipment, all the way to UAV flight labs. By the time you graduate, you're already professionally experienced to handle the workforce. I think one of the key distinguishing features of mechatronics over mechanical engineering is the fact that you are doing courses across many different departments. And this means that each of them should excel in that area. So for the mechanical area, you'll be situated within mechanical engineering. For the electrical, you'll be drawing on courses that are foundational to that area. And then also having an array of different software engineering courses you can leverage within the IT discipline. So each year, students are provided with a brief on a problem they have to solve, and this is known as the Woolman design problem. For example, students have to find an innovative way of moving objects from one location to another using unusual types of mechanics to do it. And they have to then solve this problem collaboratively in a group scenario, come up with a solution, and then compete with other students to see who's got the best design. One of my favourite subjects is the Aerospace Dynamics and Control course. In it, students learn how to design fixed-wing, rotorcraft and spacecraft vehicles. They start off with working out those fundamental engineering ideas, and then they get to apply it to a small drone that every student gets to work on. They get to build a fixed-wing glider during the course of the program, and finally get to do high-fidelity simulations of spacecraft orbital dynamics. Some of the benefits of doing the combined undergraduate and graduate pathway is that it gives you flexibility. Flexibility to choose areas like breadths, to be able to tailor the type of subjects you want to do. So you'll come out as an engineer with a much more diverse set of problems you can solve. At the master's level, you get to continue to work on mechatronics areas, really fine-tuning your skills. The degree culminates in a final year capstone project, which is a year-long project where students spend 25% of their time working with a group of other students on a really open problem, a problem that we really need to solve to address societal needs. These can be working on rehabilitation robots, it can be thinking about designing a UAV that can deliver aid to a remote location, or it could be trying to find more efficient ways of designing transportation systems to decrease our carbon footprint. Mechatronics leads into a whole range of different types of areas, from robotics to automation. So many of our alumni work in companies you probably have heard of: IBM, Honeywell, some more fun ones like a brewery. All these areas have a place for a mechatronic engineer. Automation in Australia and globally is ever increasing, requiring more and more engineers to help solve these real-world problems. At the University of Melbourne, we develop fundamental techniques to understand how to break down problems. This means that when our engineers graduate, they can solve the problems of today and the problems of tomorrow.